So we are in QGIS and we are going to demo QGIS tool. Let's open a new file. So NADI has a QGIS plugin that can show you these 4 commands from processing. To install the plugin, you basically go to your plugin, manage and install plugin, and you have to turn on the experimental plugins because NADI currently only has experimental plugins for QGIS. So once you have it checked on, you can go here and search NADI and you will find this plugin and you can install it. So your NADI GIS needs to be in path because that's how this plugin uses it. Or you can, instead of installing from here, you can download the zip from GitHub releases page, and then you will get the version of NADI with Windows executable there. So when I say NADI needs to be in path, I basically means when you enter NADI JS in a terminal, it should run the NADI JS. So this is the program with all these functions that QGIS plugin will internally use. So there are different plugins. We can start with downloading data. So you need USGS site ID and then what type of data you want to download. So let's first go here and you can search USGS station Smithland. So you will get this, or you can also get like, so basically any station you are interested in, and then all you need is basically this station number. But I wanted to show you, so if you notice this map, this is what you can see when you go into a station's page. It has this river line, point, and this basin, and it also has information about other stations. So all this data are available from their API, so you can directly access it through their API. So I'm seeing it in a JSON format. So if I replace this with our station, I basically get this data which has the name of the station, type, coordinates, and then it will all like, it also has this navigation links which you can go and then look at what data are available. So if you want tributaries data, you can get it from here. So there is NHD plus flow line. So basically there is a lot of data available, and this is what this download option uses. So we give site number and I say okay, I want basin. You can save it in a file, or I'm just leaving it temporarily stored. So you run it and then it gets your basin at that location. So this is the same as the one you can see here, but now you have it in QGIS. So there is also like USGS stream mapper. That's another plugin that you can download that can download this data, but it does like, we need a little bit more feature into that, and they want to keep it simple and not add as many features. So I'm just added these functions here. So we also want tributaries. So this will download all the tributaries streamlines from NSD Plus into our JS. It will take a little bit time because we chose Ohio Basin at Smithland, which is pretty large. Okay, so we have all the streamlines here. You can make it a bit transparent and then turn on map, so you can see this basically like has the main Ohio as well as lot of other small tributaries. So since we are trying to do network detection, let's also download USGS sites. So we have the points that we want the network with. Okay, so now we have all these locations where there is USGS gauges, and we have the stream. So the other tools are checking stream, finding connection, and stream order. So let's go with check streams. So you give that tributary here, and then reverse stream network direction is when your GIS data has the stream data in the geometry in the reverse order, which you can normally find out when you run the check stream first time without the option. So here we can see there is only one outlet, and there is a lot of branches, and confluence and origin are valid points while branches are not valid, and outlet is only invalid if there is more than one, but there is only one outlet, so that's a perfect. But we have a lot of branches, and if you see a branch like this that immediately converges will not be a problem for us, but you can like manually check if there are any branches that do not converge and kind of goes all the way to the other river or something. Then NADI detection, since it ignores branches, will be problematic. So you can also correct those things. In future we might be able to make tools that can detect these short branches, or if it is a longer one kind of, but we don't have that feature yet. So be sure to know what you are dealing with. So for now let's just ignore this. Now we have the stream order, a tool that basically takes the streams, again same system, but when you run it, it categorizes those streams into different category based on the number of tributaries they have. So this is our output. So basically it will look through them and see how important they are based on number of tributaries they have. So currently it's not using any external data like stream flow data or river width or anything like that. It's basically simply summing up number of geometries that are upstream of a river network, like river segment here. So you kind of get this naturally thickening as you go down, which is made by symbology based on the order of the stream. So you can use this for visualizing your river, which will look little bit better compared to the default one where you have everything with the same weight. And you can also choose to not show the very tiny tributaries and kind of only show the main ones depending on the degree. But of course you can also choose this to choose the symbology here and change this value to something that you think would be more acceptable. You could do 50 here, so you get a little bit more tributaries. So you can adjust those things and get a value that you want. So the next one is so we have the streams that are ordered, but we don't really need that. We can use the raw stream as well. So once you have the stream data and then you have points of interest, here are our points of interest are USGS gauges, which might be in the river, or it might be a little bit far away from river. We have some in the river, like so. Yeah, data will might not exactly match, but so we can use the connection tool. You give stream network, you can use either one of these, and you give your node points. You are using that, and you can also use a primary key, which is basically the identifier that will be used for your node connections. Let's try one with simplified connection and another without. So you can save output network in a file and snap line in a file, as well as you can save the network in a text file that you can load directly into NADI system. So let's run it. Okay, so we have our network. Since I simplified it, it will only connect like each point directly with their outlet. So you get something like this. So all this point will go through the river, and the next site it can find is right here. So that's how it went there. So we can run the same thing again with our points. So in this case, like, let's not simplify connection, so we get the whole stream. Okay, so now we can see if we turn this off. Yes, so blue is the actual stream network. Let's make this point larger. Okay, let's use this. So as you can see, this point, for example, goes all the way down and gets here, but there are no other points here until it gets to this location on the river. But as you can see through this, so it's like one of the most easiest mistake I have seen in this algorithm is that if the river is really wide and there is a tributary coming from the side, so like when you have a tributary like this and a point here, so this algorithm will try to find the closest point on the river and then kind of snap into it. But as you can see here, the tributary ended up being closer geometrically compared to the main stream, because it's so close to the edge, and this river is really wide. So this is one of the limitations right now. So one way to deal with it is to kind of in a post processing, you can load it into NADI system, and you, while doing analysis, you can look at different parameters, like different attribute of this point. Like when you look at the upstream basin area of this gauge, you can see that doesn't match up with other locations. So I don't know whether this one is correct or not. So for this, you kind of have to sometimes manually check and sometimes make sure your data are valid with each other. So for at least USGS stream gauges, there is a database from EPA and USGS called gauges locations, which already has this location snapped to the NLD plus streamline. So this will be moved here. So you can use that or similar other methods to kind of fix that. Other than that, I think it's doing a good job in other locations. Yeah, sometimes like they are not as close to the river, so the snapping sometimes kind of doesn't work if there is side tributaries. Yeah, I don't think it happens a lot in other tributaries, but it is little bit common in the main stem Ohio because of the width of the river. Yeah, but if there is no tributaries on the side that's really close, then it's fine. Now this one I'm not sure which one it should go, but you can look at its attribute and check to make sure. So this one says, yeah, this is not in Ohio River, so you can look at that name and make sure that is true. Yeah, we can explore how to check for those errors and other errors that could happen because of many other reasons using this network information into NADI system by doing the network and analysis of the metadata part.